Today we are here to discuss philosophy of mathematics. Let me wait for my students to show up online. Also, please, if you are online, Francis, okay, Francis, you are welcome. Please, Francis, tell others. I can't see them here. Don't understand. I told you guys we are going to begin this thing at exactly 8:15. Where is Augustine? Where is Francis? Huh? Where are they? Where is Fidelis? This is modern age. Is it that they don't know how to make use of technology? I don't understand. Augustine is asking me on WhatsApp. Is it on YouTube? Please reach out to them. Tell them how to follow my channel and then join in. We don't have time. Please, Francis, reach out to your brothers. I don't understand. I don't know why they are not here. I'm waiting for them to join in, please. Francis is already here. I can see you, Francis. Good. I told them to ask questions if they are confused when I forwarded the link. They didn't ask. France, please tell your brothers to join in. I'm waiting. Let them just follow the channel and join the live. Subscribe and join the live. Once they click follow, subscribe, I send them the link. They will see live on my DP, on my YouTube DP. Let them click on it and join the live. It's very easy. Francis, if you can hear me, say yes. Just say yes if you can hear me, Francis. Francis, if you can hear me, say yes. Say yes. Type yes. Francis, where are they now? Where are they? Augustine is here. Where is Fidelis? Where is Fidelis? If Fidelis is confused, tell him to check my WhatsApp status update. I've dropped the link there. Tell him to check my WhatsApp status update. Let him, he can join from there. Where is Fidelis? Augustine, I can see you. You are welcome. Where is Fidelis? Where is Fidelis? If Fidelis is here, let him say hi. If Fidelis is here, let him say hi. Fidelis, if you are here, please say hi. Fidelis, if you are here, please say hi. Okay. I hope you can hear me loud and clear. I hope you can hear me. It's clear enough, right? Give me a signal. Just say yes. If it's clear enough, say yes. Can you hear me clear enough? Okay. Okay, philosophy of science. We are here to talk about philosophy of science. Philosophy of mathematics. Sorry. What I want to do with you today is just to give you an introduction of what the course is all about. So we are not. It's just to introduce you to the course. Now, philosophy of mathematics is the philosophical study or investigation into the nature of mathematics. So, as you already know, philosophy is a versatile discipline. It's very, very vast. Okay? There is actually philosophy of everything. There's philosophy of education, philosophy of science, philosophy of biology, philosophy of medicine, philosophy of physics. So, it's a discipline that speculates on virtually every aspect of human life. You understand? So there is no aspect of human life that philosophy does not investigate. It investigates everything. So this particular branch of philosophy is the one that investigates or speculates on the nature of mathematics. So before we begin to talk about philosophy of mathematics proper, we need to do a brief introductory analysis of what mathematics itself is, because you cannot be able to understand philosophy of mathematics if you don't have basic knowledge of the nature and principles of mathematics. So there is need to first of all explain and explore what mathematics itself is. So the question now is, what mathematics? What then is mathematics? What is mathematics? Please, Augustine and Francis, remain online. Stop switching off and on. Remain online. If I'm too fast explanation, call my attention. I will repeat. You can be making a note also, because this is actual class. You can be making a note. If I'm too fast, call my attention. I will slow down. Make a note. I will also send you a brief summary of this lesson at the end of this section. So it is actual class section. Don't play with it. You have to be focused. So now, what is mathematics? For us, like I said, for us to understand what philosophy of mathematics is, we have to be able to know what mathematics itself is, what it is concerned with. Now, simply put, we say mathematics is the systematic study of numbers. quantities, patterns, structures, and relationships using logical reasoning and symbolic representation. I said that mathematics is the systematic study of numbers, patterns, structures, relationships, using what? Using logical reasoning and symbolic representation. That is what mathematics is. Mathematics is the systematic study of numbers, patterns, structures, relationships, using what? Logical reasoning and symbolic representations. All those things you see in mathematics, they are symbols: equal to, minus, plus. So you study patterns, you study numbers, you study quantities using symbolic representations and logical reasoning. That's what you do in mathematics. Okay, so in mathematics is a discipline where we study numbers, we study quantities, we study the patterns of these numbers, and we study the relationship of these numbers, how they relate to each other. And we do these studies using symbolic representation. We use symbols in the studies, and then we use logic, we use reasoning. Mathematics is more of logicality than experience. Now, the word mathematics, let's look at the etymological root. Where did it come from? The word mathematics comes from the Greek word mathema, M-A-T-E-M-A. That's where that word comes from. It comes from the Greek word mathema, M-A-T-E-M-A, M-A-T-E-M-A. That's the origin. And that Greek word mathema, M-A-T-E-T-H-E-M-A, that Greek word means knowledge, learning, or science. Of course, you know, the Greek is one of the foremost human civilizations. Almost everything we know about education started from what? From the Athenians, the Ionians, the ancient Greek scholars. So mathematics too is of Greek origin, specifically Pythagoras. So, and from that Greek origin, the Greek root word from which the concept and term mathematics originate is the word, the Greek word mathema, M-A-T-H-E-M-E, E-M-A, and that word means knowledge, learning, or science. So, as a discipline, mathematics is one of the oldest intellectual disciplines. It is one of the oldest of all intellectual disciplines, apart from philosophy. In fact, you can even say mathematics has almost the same age as philosophy, even though, yes, rationally or critically, we can say that mathematics is one of the first fields that detached itself from the shadows of philosophy as arithmetics. But it is, apart from philosophy, it is one of the most ancient branches of human intellectual activities. Okay? And all the foundations of sciences, whether physics, engineering, geometry, computer science, and all whatnot, even medicine, they are all founded on mathematics. So it is very, very old. It is very, very old. Now, what are the characteristics of mathematics? What are the characteristics? What are the qualities? What are the features? What are the things that when you see a mathematical representation, you see those signs, you see those qualities embedded in them? The first characteristic of mathematics is the use of symbols. Use of symbols. Almost everything we do in mathematics deals with symbolization: plus, minus, equal to. Even the variables a, x, y, z, they are all symbols. There is no mathematics without the use of symbols. Even the numbers themselves are symbolisms. They are symbols. So use of symbols is one of the major characteristics, one of the major features of mathematics, excuse me. Is one of is one of the major features of mathematics. There is no mathematical representation that is done without symbolization. None. All the mathematical representations, all the patterns, all mathematical representations, patterns, circle, square, they are all represented using symbols. So use of symbols is one of the major characteristics of mathematics. Another one is logical reasoning. Logical reasoning. Mathematics depends heavily on logic. Mathematics depends heavily on the use of logic, whether deduction or induction. Mathematical statements are proven. All of mathematical statements are proven through logical steps known as proofs. All mathematical reasoning statements, if you want to solve a mathematical question now, you use logical, you follow logical steps. You follow steps. Those steps are logical. They are based on logical reasoning. When you say 1 plus 1 equal to 2, is logical. You can say it's deductive, if you like, inductive, because you can progress from 1 plus 1 equal to 2. You can progress from the other side, 2 equal to 1 plus 1. So it is founded on logical reasoning. I've mentioned two important qualities or features of mathematics. The first one is what? Profound use of symbols. The second one is what? Logical reasoning. There is no mathematical representation, calculation that is not based on logical reasoning. And that is why in mathematical calculations you do a lot of proofs, and those proofs are presented or proved using logical reasoning. So when you say 2 plus 2 equal to 4, is a logical reasoning, because 2 plus 2 equal to 4 can also be 4 equal to 2 plus 2. It can also be 4 minus 2 equal to 2. So it's logical. It's logical. Then the third quality of mathematics is precision and exactness. Precision and exactness. Precision and exactness. Precision and exactness. Unlike ordinary language or other disciplines, mathematics is always exact and precise. Remember when we are doing phenomenology, or maybe very soon you do Cartesianism, or maybe if you have done early modern philosophy, you discover that what most of the early modern philosophers, they were propelled to begin to do philosophy using mathematical method. People like Francis Bacon, even René Descartes, they were inspired by mathematics in their philosophical method because of the precision and exactness of mathematics. For instance, when Descartes was doing the cogito ergo sum, he wanted to develop or form a method for doing philosophy that can lead to what? And to exact, distinct, and precise knowledge. So, precision and exactness is the hallmark of mathematical knowledge. Every mathematical knowledge is precise. It is exact. And that is why what is proven to be correct in Nigeria mathematically is always correct everywhere. 1 plus 1 equal to 2 is exact and precise. Is the same every day, every time, anywhere across the universe. You understand? So, precision and exactitude or exactness is the hallmark of mathematical knowledge. Every mathematical knowledge, every mathematical proof, every mathematical finding is always precise. We don't have about, maybe, could be in mathematical answers and knowledge. It is always yes or no, this or that. So precision, exactitude, exactness is one of the major qualities of mathematical knowledge. Then another one is universality. I've already explained this thing. Mathematics and mathematical truth or knowledge is universal. Mathematical findings and conclusions are are always the same. The results are always the same everywhere. The result of a mathematical proof or calculation is the same in the US, in England, in Nigeria, in Asia, in any part of the world. 4 plus 1 is equal to 5 is the same everywhere. 4 minus 1 equal to 3 is the same everywhere. If you go to the mountain, go to the valley, go to Africa, go to the America, go to the Pacific Ocean, 4 minus 1 is always equal to 3. So the knowledge is always the same everywhere. So it's universal. So these are the 4 major qualities. These are the 4 major qualities or characteristics of mathematical knowledge. Let's repeat them. The first one, we said what? The first one is that what? Mathematical knowledge. Mathematics uses what? Symbols. That's the first characteristic we mentioned. Then the second one is that what? What's the second one? Let me show that you are listening. What's the second one? Let me show that you are listening. If you are there. If you are there, let me show that you are listening. What are the 4 characteristics I just mentioned of mathematical knowledge? I want to see whether you are following me. What are the 4 of them? I mentioned 4. The first one is use of symbol. What are the remaining 3? Francis, type it here. Type it. Augustine and others online. Type it. I've mentioned 1. Use of symbol. Use of symbol. Yes. What are the remaining 3? Yes. Francis Ogodo said symbol. Is use of symbol. What are the remaining 3? Use of symbol. Yes. What are the remaining 3? Type it here. Logical reasoning. Yes. Remaining 2. Augustine, you are not responding. Logical reasoning. What are the remaining 2? Exactness. Yes. Very good. Thank you, Francis. You are following. So, use of symbols, logical reasoning, precision and exactness, they are 1 point. And the last one, universality. Universality. They are very, very important. Keep them in your mind. Keep them in mind. Okay. Now, the next thing we are going to look at the major branches. The major branches of mathematics. The major branches of mathematics. Mathematics is a very vast field of study, but there are different branches. Now, there are different areas of studies in mathematics. Some of the branches are, one is arithmetic. Arithmetic. Because mathematics is almost always arithmetically inclined. Some people call mathematics arithmetic. But arithmetic is just one of the aspects of mathematics, one of the several branches or aspects of mathematics. Arithmetic, A-R-I-T-H-M-E-T-I-C, arithmetic. So, arithmetic is the study of numbers and basic operations. That's how we defined it. It's one of the major, if not the chief branch of mathematics. Arithmetic is the study of numbers and basic operations. And you know, basically, like we defined at the beginning, mathematics is the study of numbers. So that is why sometimes, especially if you look at our parents in the old days, most of them prefer to call mathematics arithmetics. So some of us grew up thinking that mathematics is the same thing as arithmetic, or arithmetic is another name for mathematics. No, it is just a branch. But why it almost takes over the name of mathematics is because it is the heart of mathematics, because it is the study of numbers and basic operations. So in essence, all those mathematical operations we have, subtraction, addition, multiplication, all of them, square root, they are all arithmetic. So it is the study of numbers and basic operations. All mathematical operations are classified as arithmetics, whether subtraction, addition, multiplication, division, finding of square roots. All are they are operations. They are basic operations. So they are classified as arithmetic. Arithmetic. Now, the next branch of mathematics is algebra. 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 A-L-G-E-B-R-A. Algebra. A-L-G-E-B-R-A. Now, what is algebra? Algebra is the study of symbols and unknown quantities. Algebra is the study of symbols and unknown quantities. If you remember when you were in your basic level education, primary and secondary school, you did a lot of algebraic calculations. For instance, you can say x plus 3 equal to 7. That's an algebra. X plus 3 equals 7. They will tell you to find x. And that x represents an unknown number. So that kind of mathematical operation is what we call algebra. So it's a branch of mathematics that studies symbols and unknown quantities. So whenever you see in a mathematical operation where you have unknown quantities or variables like x plus y equal to 36 or equal to 6, they'll tell you find x and y. What's the branch that kind of mathematics falls into is algebra. So algebra is another chief branch of mathematics, and algebra is the branch of mathematics that studies symbols and unknown quantities. The first branch we talked about is arithmetic, which is the study of numbers and basic operations. I hope you are following me. I hope you are following me. Okay, now the next branch we are going to look at is geometry. I've mentioned and explained arithmetic, algebra. The next one is geometry. Geometry, G-E-O-M-E-T-R-Y. And what is geometry? So geometry is the branch of mathematics that studies shapes, sizes, and spatial relationship. It's the branch of mathematics that studies shapes, sizes, and spatial relationship. When you were in your basic level education, primary, secondary school, you did a lot of mathematical calculations, operations that concerns shapes like circle, triangle, parallelogram, square, rectangle, and so on. They are all algebraic. So the branch of mathematics that studies shapes, sizes, and spatial relations, longitude, you did longitude, latitude, and so on. All those things fall under mathematical geometry. They fall under the branch of mathematics that is called geometry. So the branch of mathematics where you do calculations relating to circles, triangles, squares, angles, parallelogram, all whatnot, including longitude and latitude, because those things that are circles and triangles or angles that are used to measure relationship in the space, spatial relationships, they all fall under geometry. I hope I'm making sense. Francis and Augustine and others. I hope I'm making sense. If you are not following me, call me back. Okay? Call me back. I'm going to repeat. If you are not following me, call me back. Just say it on the screen. I will go back. Anything you do not understand, anything you didn't grasp adequately, just say it. I'm seeing you on the screen. I will go right back and explain. Okay? It's a class. There should be an interaction, even though we are not meeting in person, but it doesn't change anything. This is a technological age. Anything you don't understand, call my attention. I will go right back and touch on it. So we are looking at the major branches of mathematics. I've explained arithmetic, algebra, geometry. Now, the fourth branch we are going to look at is calculus. 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 And what does this branch of mathematics, what does it do? Calculus is the branch of mathematics that studies change and motion. It is the branch of mathematics that studies change and motion. And this branch is applicable a lot in physics, engineering, and economics. All those branch of mathematics you do in your basic education, primary, secondary school, where you calculated distance, speed, acceleration. In physics, where you calculated force, momentum, equilibrium, and the rest of them, they are all under the branch of mathematics that is called calculus. The branch of mathematics where you study motion, change, time, speed, distance is called calculus. And like I said, it applies a lot in physics, engineering, in economics. I hope it's clear. All right. Then the next is statistics. So if you check now, we have done how many? 5. We have done arithmetic as one of the branch of mathematics, algebra, geometry, calculus, and statistics. So you know what statistics is already. Statistics is the branch of mathematics that studies data collection, analysis, and interpretation. The branch of mathematics where you are given, you do graph, pie charts, graphs, pie charts, bar charts, and so on. All forms of charts that involves calculation is what we call statistics. So it is the branch, statistics is the branch of mathematics where mathematics is focused on the study and on the collection and study of data, the analysis of data and interpretation of data. Okay, so that is what statistics is about, and it's a branch of mathematics. You see it a lot in population studies, in opinion polls, and economic and in economic data calculations. For instance, when you are doing the relationship between demand and supply in economics, you are using what? Statistics. That is mathematics. If you are doing opinion poll or even collecting data on a questionnaire, what you are using is statistics, is mathematics. If you are doing population studies, what you are using is statistics, is mathematics. Yes, Fidelis, I can see you. You are welcome. It's just that you are late. The class is already almost 30 minutes spent. But you are welcome. I hope we are together. So these are the 5 major branches of mathematics. These are the 5 major branches of mathematics. Can I see your reactions online? I have mentioned 5 and analyzed them. Can you mention the 5? The first one is arithmetic. What are the remaining 4? What are the remaining 4? 5 branches of mathematics I have enlisted. I enlisted and explained. Okay, algebra. Yes, Francis, that's correct. Which other one? Algebra. Which other one? Geometry. Very good, Francis. Which other one? Algebra, geometry, arithmetic, calculus. You have gotten 4. Is remaining 1. What's the last one? Statistics. Very good, Francis. Very good, Francis. You are very, very active. I'm happy. You are very, very active. Very, very good. Very, very good. Very, very good. Very, very good. Which of them is used? Which of them is used for population studies? Which of them is used for population studies? Which of these 5 branches you have mentioned is used for population studies? Which of them is used for population studies? Which of them? Which of them? Very good. Statistics, very good. The statistics, very good, very good. The statistics. The statistics. Which of them is used for the study of shapes? Shapes like circles, triangles, squares, and angles, even parallelogram. Which of them is used? Which of them studies shapes, triangles, rectangles, circles, angles, latitude, longitude, space, shapes, and and spatial relations? Very good, very good. Very good, Francis. Geometry. Very good, very good. Augustine, are you still here? Are you still here? Don't worry, gentlemen. You will get used to it. It's actually a very interesting way to learn. Online learning is very interesting. Personally, I even prefer it than facial contact. Okay, that's by the way. That's by the way. So let's go back. Let's a kind of do a very fast and sharp summary of what we have done. So we have done just 3 things. We have done just, okay, let's say 4 things. We did a very rough analysis of what, explanation of what philosophy of mathematics is. And we said that what is the branch of philosophy that studies the nature of mathematical objects, mathematical truth, and numbers. Then I proceeded to say that for you to be able to perform well and understand what philosophy of mathematics is, there is need for us to do what? To run through or go through the nature of mathematics itself. And that leads us to what we are doing now. We proceeded to define mathematics. And I said that what? Mathematics generally is defined as the systematic study of what? Of numbers, quantities, patterns, structures, and relationships. Is the systematic study of numbers, of quantities, of patterns, of structures, and of relations. Yes. Using logical reasoning and symbolic representation. I said, while attempting a definition of mathematics, that mathematics is the systematic study of numbers, quantities, patterns, structures, and relationships. It doesn't end there. What is used for this study of numbers, quantities, patterns, structures, and relationships? It is what? Logical reasoning and symbolic representation. And I told you that mathematics is an ancient discipline, just like philosophy. It originated from ancient Greek, the Ionian scholars. And because of that, it got its name from a Greek word. That is its etymological root. It got its name from the Greek word mathema, M-A-T-E-T-H-E-M-A, M-A-T-H-E-M-A, mathema. And that Greek word mathema, from which mathematics derived its name, it means what? It means knowledge. It means knowledge. It also means learning. It also means science. It means what? Knowledge. It also means learning. It means science. And it should not be surprising to you that mathematics takes its root from Greek, because you cannot mention education without the Ionian scholars, the Athenians. And remember, you already did Pythagoras in ancient Greek philosophy. Pythagoras is the father of mathematics, and he's a Greek. His philosophy is about numbers. He's the one that argued that what? That number is the stuff of reality, that everything in being, everything in existence is made up of number. So he's the father of mathematics. He's the one that owns this discipline. He founded it. He is the first philosopher of mathematics. His philosophy is mathematics. His philosophy is number. So this underpins or underlines or exemplifies the ancient Greek Athenian root of mathematics, From there, we proceeded to discuss the characteristics of mathematics. We proceeded to discuss the characteristics of mathematics. And one of them is that what? We said the use of symbols. There is no mathematics without symbols. Everything, almost everything about mathematics is symbolization. Addition, subtraction, equality sign equal to variables and the rest of them. That's the first characteristic we mentioned. Then the second one we mentioned is logical reasoning. Mathematics is inductive, is deductive. It's not based on experience mostly. It is mostly based on what? Rationality. It is not always empirical. It is based on rationality, on critical thinking. Then the next one we mentioned is precision and exactness. Precision and exactness as another characteristic of mathematics. Precision and exactness. That mathematics is always exact, precise. That the findings, the conclusion of mathematics is always exact, is always precise. We don't have nearest to the right answer. We don't have answers like about, maybe, perhaps, almost. It is always yes or no, this or that. It's precise, it's exact. That is the conclusions and the proofs, the results of mathematics. And then the next characteristic we talked about is universality. What universality suggests is that what? Every mathematical operation, the procedure, the process, and the conclusion is always the same everywhere. For instance, 2 plus 2 is equal to 4. It's the same in Africa, it's the same in Europe, it's the same in America, it's the same in Asia, it's the same on the mountain, in the valley. So the results and conclusions of mathematics are always the same everywhere. So it is universal. And from there, we proceeded to talk about what? To talk about... Okay, please, sorry for the break. Please, if you can hear me, say hello. If you can hear me, say hello. I'm back. Sorry. I went offline a bit, but I'm back. Please, if you are still with me, say hello. If you are still here, if you can still hear me, let me hear you, please. Let me just react. Okay. Thank you. Augustine, are you there? If you are there, Augustine, say hello, please. Say hello. Augustine, Francis, and so on. Okay. Sorry. I had a little network fluctuation, but I'm back. Now, I talked about already the major branches of mathematics. Arithmetic, algebra, geometry, calculus, and statistics. And I explained that arithmetic has almost taken completely the name of mathematics. If you remember, most of our parents, they call mathematics arithmetics. But arithmetic is just a branch. But why most parents seem to have made arithmetic the synonym for mathematics is because it is the most crucial branch of mathematics, because it is the branch of mathematics that most completely captures what mathematics does, the study of what? Numbers. So arithmetic is the study of numbers and basic operations. So all those aspects of mathematics that has to do with addition, subtraction, multiplication, division, and so on are classified under the branch of mathematics that is called arithmetic. Then algebra. Algebra is the branch of mathematics that studies symbols and unknown quantities. The branch of mathematics that studies symbols and unknown quantities. For instance, when you say x plus 3 equal to 7, you say 3x minus 2 equal to 8. Find x. All those aspects of mathematics where you have operations that challenges you to find an unknown variable, an x, a y, or a z, we call them algebra. Then geometry. Geometry is the branch of mathematics that studies shapes, sizes, and spatial relations, longitude, latitude, circles, triangles, squares, angles, and all whatnot. Every mathematical operation that has to do with the study of space, of circles, of shapes, be it circle, triangle, square, angles, longitude, latitude, spatial relationship. They are all classified under geometry. Then calculus. Calculus is the branch of mathematics that studies change and motion. Is much applicable in physics, in engineering, and economics. When you were younger, the aspects of your studies where you did calculations concerning speed, distance, motion, acceleration, deceleration, equilibrium, force, all those things are classified under the branch of mathematics that is called calculus. And then statistics is the last one. It concerns the study of data and data collection and analysis and interpretation of data. So you see statistics applied in aspects of human endeavors like population studies, opinion polls, and economics, especially in the calculations of demand and supply, population density, and the rest of them. You see, I have gone full cycle repeating what I did already because I want you to follow. I want you to understand. I want you to get it right here and now. Okay? Now, we'll move to something new. The importance of mathematics. Why is mathematics important? Today, you go to every country of the world. Mathematics is one of the compulsory disciplines people do throughout their basic level, from primary to secondary. In fact, to a larger extent, in most countries and civilizations of the world, even at tertiary level, university level, people are still expected to do mathematics as GS course in their year 1 and year 2. So it is very crucial in human endeavor. It's very crucial, it's very, very important. So why is it important? So I'm going to give you about 4 important reasons why mathematics is crucial, it's very important for us as humans. One is scientific development. Scientific development. Scientific development. Scientific development. Scientific development. Mathematics is the language of science. There is no science without technology. All scientific innovations, all scientific breakthroughs, the foundational logic behind those breakthroughs are mathematics. Be it the production of mobile phone, of helicopters, aeroplane, refrigerator, television. Mathematics is at the foundation of all those discoveries. So mathematics is foundational, is a prerequisite, is an essential requirement for scientific development. There is no science, no human civilization, no development without mathematics. Because every scientific discovery is chiseled, refined, and consummated using mathematics. So mathematics is very, very important for scientific development. Then the next one is technological advancement. The explanation is almost the same as the first. For technological advancement, modern technologies such as computers, satellites, telecommunications, and so on, all depend on mathematics. Even the phone call we make, even the flight, aeroplane, and the rest of them, they depend on mathematical calculation. As a pilot, you cannot go with your craft without the map, and you read the map using mathematics. Map reading is done using mathematics. Okay, so technological advancement of all sorts is propelled by mathematical knowledge. There is no computer, no satellites, no telecommunications, and others without mathematics. So it is crucial and essential for technological advancement. Then, problem solving. Mathematics helps people to analyze problems and find solutions. You cannot solve your problems without mathematical knowledge. All the predictions, postulations, inductions, and even deductions, or even presumptions and assumptions we make them based on mathematical calculations. We make them based on mathematical calculations. You cannot make any of those inferences or any of those guesses without basic mathematical knowledge. So, mathematics is necessary for problem solving. If you have a good problem solving skill, there is a high tendency that you have a good logical reasoning capacity. And good logical reasoning capacity is foundational to mathematics. So, problem solving is one of the significance of mathematics. Then, economic planning. Economists use mathematics to study and plan about the future. For instance, issues like or problems like inflation, population growth and density, and the movement in the financial markets, demand, supply, all those things cannot be analyzed by economists without mathematics. Population control and the rest of them. Figures for population density, movement in the market about demand and supply, and so on. They are all done using mathematical knowledge. So the importance of mathematics is seen in scientific development, technological advancement, problem solving, economic planning. You can add others, but these four are foundational. They are crucial. Now, having said that, we have done a background and foundational analysis of mathematics as a discipline. Now we have to look at the philosophical aspects. Now that we have known mathematics, okay, let me see. Let me test you. Basically, what do you think mathematics is? Type it there. From what I have explained so far, before I begin to talk about philosophy of mathematics, because that's the next thing we do before we round off today. From what you have heard and maybe understood, what do you think mathematics is? What do you think mathematics is? Let me see your reaction on the screen. Type. Our time is ticking fast, please. Just type. Let me see. Type. Let me see your reaction. What do you think mathematics? How do you define it? How do you describe it or even explain it? Basic understanding from what I have said so far. Yes, let me see your reaction. Franz, Augustine, Fidelis, and others online. Let me see. Anybody? I'm waiting for your reaction. Yes, can I see your reaction? Mathematics is the study of language of patterns, number, structure, and logic. Okay, Francis, that is fair enough. That's fair enough. It is okay. It's the study of not language of patterns. It's the study of numbers, patterns, structures, and qualities. Look, very important. You must add in that definition using what? Using logical reasoning and what? Symbols. If you don't add it, you have thrown away one important aspect of the definition. Okay? It is the study of numbers, quantities, structures, patterns, etc. using logical reasoning and symbolic representation. If you like, just say symbols. Okay? Okay, now, since we have gathered the basic, we have seen the basic understanding of mathematics. Now, what then is philosophy of mathematics? What is philosophy of mathematics? What is the concern of philosophy of mathematics? Now, philosophy of mathematics is the branch of philosophy. Philosophy of mathematics is the branch of philosophy that studies the nature, meaning, foundation, and truth of mathematics. Philosophy of mathematics is the branch of philosophy that studies the nature, meaning, foundation, and truth of mathematical knowledge of mathematics. That's what philosophy of mathematics is. It's the branch of philosophy that studies the nature, the meaning, the foundation, and the truth of mathematics or of mathematical knowledge. Philosophy of mathematics studies the nature of mathematics, the meaning of mathematics, the foundations of mathematics, and the truth of mathematical knowledge. That's what it does. So, in essence, philosophy of mathematics examines deeper questions about mathematics, such as what are numbers? What are numbers? What are they? It asks questions like, what are numbers? These are deep questions that borders on the ontology of mathematics. It asks other questions like, do numbers exist independently of the mind? This is the Platonic problem. Okay, Fidelis, I saw your definition. Okay. So I'm talking about the questions that philosophy of mathematics raise about maths. It asks the question, what are numbers? One. It also inquires, numbers, do numbers exist independently of the mind? Or are they mind-dependent entities? Is a problem created by Plato. Of course, Plato is one of the strongest philosophers of mathematics. So this is a perennial, is a very big problem. Exists outside the mind, or their own level. For instance, 8. Can you see an 8 in the real world? Or is this something that is conceptually understood? Is it something that is just an idea in your head? Or can you see an 8 in the real world? Or could there be a kind of mediation of the both? That yes, is in the mind and is also in the world. It's one of the problems that we investigate, one of the questions we raise in philosophy of mathematics. Do numbers exist independently of the mind, or they exist only in the mind? Are numbers and other mathematical entities, not only numbers, even we call them mathematical objects, squares, shapes, are they only existing in the mind, or do they exist or are capable of existing outside the mind? Then the next question is, how do we know mathematical truth? When we say 2 plus 2 is equal to 4, what makes, can 2 plus 2 to 4 be subject? Is it experiential? Is it experimental? Is it pragmatic? Or is it logical or commonsensical? Is it intuitive? So how do we know mathematical truth? How? Yes, we know mathematical truth, but how do we prove it? How do we know it? How do we explain it? How do we manage? How did we manage to come to the knowledge of mathematical truth? How do we express it? Then the next important question my philosophy of mathematics raised about the nature of mathematics is mathematics invented or discovered? Is it invented or discovered? Invented, was it created by man, or is it part of the human nature that sometime in the course of human civilization and development, the human person somehow discovered the mathematical scale? So these questions, if you look at it very well, they move beyond calculation. And that's why they are philosophical. They move beyond calculation into philosophical reflection about mathematics itself. So why mathematics deals with the calculation, the proofs of mathematical truth? Philosophy of mathematics moves beyond the calculation and borders, centers, deliberates on what? On the reflections on the mathematical truth in themselves. I hope you are following me. When is this lecture period supposed to end? Is it 9:20 or what? Guide me, please. Is it 9:20? So that I don't keep you beyond your show. When I was supposed to stop this, is it 9:20 or 9:30? Okay, let me just touch on the last aspect of what. Okay, 9:30. Okay, thank you, Fidelis. Let me just touch this next 10 minutes. We are going to look at two things: the origin of philosophy of mathematics, and then we look at it's still big, man. Okay, if we don't finish it, I'll send you the note. Next time we'll continue. Now, if you talk about the origin of philosophy of mathematics, I already told you the philosophical study of mathematics began in ancient Greek. The Greek philosophers, specifically Athens, the Ionian philosophers, they started it. So one of the earliest thinkers to reflect deeply on mathematics was Pythagoras. I said that already. Pythagoras, who believed that what? Numbers form the fundamental structure of reality. Remember, I did that in your year one. Pythagoras suggested that what? That number is the author of reality. That everything is made up of number. That everything have within their structure, their essence, number. Number is the foundation. Number is the soul of reality. Is the essence of existence. Everything is made up of number, including music. So Plato founded mathematics, and that was where the philosophical study of mathematics began. Later on, Plato took up the baton and argued that mathematical objects exist in abstract world or perfect form. Platonism has a lot to do with the further development of mathematics. All this about mathematical objects or knowledge or truth or facts being dependent or independent, being able to exist only in the mind or outside the mind. It was Plato that created those problems through his idea of the world of form. Remember Plato's allegory of the cave and the rest of them. So Plato was also a major contributor to the rise and development of philosophy of mathematics. In modern philosophy, in modern times, thinkers like Bertrand Russell, Gottlob Frege. Remember, I didn't say Edmund Husserl. I said Bertrand Russell. Gottlob Frege. Russell is Russell, and Gottlob Frege, Gottlob. They contributed a lot in the modern times to the logical foundations of philosophy of mathematics. So, in essence, in the nature of philosophy of mathematics, we have different types of questions. Those 4 questions I have raised earlier on. You have questions that have to do with ontology, ontological questions. You have epistemological questions. All these questions also border on the foundational laws that underline the structure and nature of mathematics. We'll explain this subsequently. I'm just trying to summarize. And now, before we go, there is need to create a relationship between mathematics and philosophy of mathematics. This is very, very important. The relationship between mathematics and philosophy of mathematics. How do these two, how do they relate? Now, mathematics focuses on solving numerical and logical problems, while philosophy of mathematics focuses on understanding the meaning and foundation of these or those mathematical ideas. One, which is mathematics, major focus is solving numerical problems and logical problems. The other one, philosophy of mathematics, focus on what? Understanding the meaning and the foundation of those problems. In simple terms, mathematics asks, how do we calculate? While what? What do these calculations mean? One is interested in results, in proofs. The other one is interested in the meaning of the results, in the meaning of the results, in the means through which the results are acquired. To put it even more simply, you can say that mathematics practices calculations and proofs, while philosophy of mathematics reflects on the meaning, foundation, and justification of those calculations and the proofs. I'm just trying to make you see the demarcation between the two. So in essence, mathematics is the practice, whereas philosophy of mathematics is reflection. Okay? Mathematics is practice. Philosophy of mathematics is theory. 1 + 1 = 2 is practice. Philosophy of mathematics is not interested in that 1 + 1 =. It is interested in the foundation. Why did mathematicians say when you put 1 and 1 together, it will be equal to 2? So, mathematics is the practice, the calculation itself. But philosophy of mathematics is interested in raising fundamental questions about the meaning of that calculation, the results of that calculation, the structure of that calculation, nature of that calculation. So in essence, philosophy of mathematics reflects on the assumptions and foundations behind mathematical practice. Okay? Is interested in what? On the assumptions and behind mathematical practice. So you can say that mathematics provides content. Philosophy of mathematics examine the foundations. Are you okay? Yeah, somebody's asking me, please, sorry, let me respond to this. Franco 766. Yes, I'm interested in set theory. I am. Franco, are you also interested in that? Is that your area? I am. I'm interested in set theory. I am. I can be a guide too to anyone that has problems with set theory. Okay, gentlemen, I'll have to let you go. But this is the extent of the class. One thing I've promised is, after every online class like this, I'm going to send you a lesson summary. You read and digest. Before the end of today. I will send it to you on WhatsApp, the summary of this lesson you just had now, so that you can digest it. You can even come back online here to this stream and take a second listen to it. So please, I won't be coming to the campus, to your school, on Wednesday, because there's only one lecture I have. Please, on Wednesdays we'll be having this class online. But if there's any major issue, I will come, you see me. But on Thursdays, I'll be coming to school for the other lessons or courses I have. So I'll meet with you again, same time, Wednesday next week. Philosophy of mathematics. Time for supporting. Like I said, I'm going to forward you a summary of this lesson through it, and interact with me, maybe here on YouTube or on WhatsApp if you have confusion. Before I go, is there any question? If we are good to go, just say yes so that I can end this the stream. Is there any question? Are we okay? Please remember this relationship I did between mathematics and philosophy of mathematics. I will expatiate on that more, but I'm sure by the time you go through the lesson summary, it will make further sense to you. All right. Have a lovely day. Enjoy your day. I'll see you next week or tomorrow at school even. Goodbye for now.